Hello and welcome to the third lecture in our 14th chapter of our comprehensive course on AI, machine learning and data science. Now, we are doing at present this thing, part C of the chapter in 14th chapter, that is saving the plots in various formats. Now, this is also one important step because most of the time we show the plot like this in the Jupyter notebook, but this is actually not a very kind of professional way of doing things. The professional way of doing things, because that makes your Jupyter notebook very heavy, memory heavy, and if it is very lengthy data analysis with say 10,000 rows and maybe 60 or 80 columns, and you are plotting the graphs for each column, then in that case the loading also becomes very slow. Further, the issue is that sometimes Jupyter notebooks start crashing and you have to scroll a lot. So normally, instead of displaying the plot in this manner, we save the plot in a separate folder as we have done in this manner. And the command is very simple for that, that is plt.savefig. So that is one important thing. And once the plot is already saved, then you can clear all the plots which you have saved, because even when you save it, they will be saved in the specified folder, but they still remain in the memory. So you can clear the current figure, or that is all the figures if you are saving multiple figures, okay, by using this plt.clf command. Okay, so then first let us take our data frame. This is my data frame, and it is that region wise sales which we have done in previous lecture also. So there are 4 regions, and this is the corresponding sales, maybe in $1,000 or something in these 4 regions of one particular product. Now we are plotting the graph. I have taken care that in each and every of this Jupyter notebook, at least in the beginning initial chapters, I have taken care that these steps are there just above the code. Okay, so I will expect that you will not directly jump to the code, but try to remember the code using this. And I'm speaking each time that plt.figure inside fig size and pass a tuple having the width and the height of the figure. Then plt.bar chart, because I want the region wise sales, so that is best classified by each region is like a group or a container. So the best way to specify that kind of graph is using a bar chart. And then plt.title, plt.xlabel, plt.ylabel, plt.legend. Here no legend will be required because we are plotting all by same color. And plt.grid, true or false you have to write, and show the plot, that is plt.showplot. Now here only this last step is removed, and instead of that what you have to do is save the plot. Okay, and how you will save the plot? By using plt.savefig, this command, in which you will specify the name of the file, that is how you want to save it. Say myplot.png or myplot.jpg, that is the various formats of images, or myplot.pdf or myplot.eps or etc. svg, like that. And next you will specify optionally resolution. DPI is equal to, DPI is the parameter by which you can specify the resolution, and sometimes it is required to save the plot in extremely high resolution. Then you can specify any resolution here subject to the capacity of your hardware. If you have a graphics card, then you can even use extremely high resolution to save the plot. Okay, remember however that when you save the plot with high resolution, it takes time to save it, and when you double click on it and open that plot, then also it takes time to open it. But if you have sufficiently powerful hardware, then you can practically there is no limit of this DPI parameter. Okay, so this is that again as usual importing the library, and now starting from here the saving steps are there. Okay, so sales by region, that is the name of the file, and that DPI equals 300. So save the PNG file. 300 is considered pretty high resolution for most applications. JPG, then just sales by region.jpg. PDF file if I want to save it, then sales by region.pdf, and so on. Sales by region.svg, that is the support vector graphics, that kind of format. And EPS, which is a format in which things will not be visible directly, but using certain softwares like Ghost Script, you can convert EPS files to PDF files. So EPS is something you can say that an encoded version of PDF, somewhat similar to that. Okay, so let us plot this, and it will take some time, particularly for this PDF, and also a little bit time for this due to this high resolution. At present, and everything will be plotted in my home directory, that is where this script is. So that is here somewhere. You will see that that plot will be displayed. Currently, no such plots are there anywhere, but I can see after a few seconds that the plots will be created here. Okay, And you can specify any path. It is not compulsory to save in that same directory. You can specify any other path by using OS and the path variable, which we have already done while doing that univariate analysis and the bivariate analysis. But I want to keep the things simple, and I want to open the file and show you that the plots are indeed plotted. That's why. Okay. So I am plotting. A message is given that plots are plotted. Now, if you see, some of them may be ready SVG, for example. So if I see this is my SVG file, okay, then this is my PDF file, okay, then this is JPEG. It is very high resolution, so very big, so I can minimize things slightly, okay. Then what else? I think JPEG and PNG was also there, right? PNG. So this is the PNG file. It is also very high resolution and therefore very big, so I can minimize for your convenience of display. So these are various files that I have displayed. Now about that EPS. That EPS is not exactly a visible format. As I said, you have to use some softwares like GhostScript, but it will be a format like this. So it is a kind of encoding to the image. But I wanted to display it because of one reason, that you should understand that ultimately in computer everything is converted into numbers. So whether it is your categorical variable which we encode and convert into number, but not only that, a image is also converted into number, audio is also converted into number, video is also converted into number. Any form of input data, ultimately when it is internally stored, it is converted into numbers. This is even not the format. Even this will be further converted into binary and then it will be saved, right? So that is one important thing. Now the question may arise is when to use which format. Okay, so PNG with high resolution is suitable for high quality print. PDF is suitable for documents where scalability is important. You should, I mean, when you want that the image which you have created, you should be able to minimize or maximize it in size and put it anywhere in the document. If you are creating a report or writing a book on data science, then PDF format is good. Then CLF, ultimately, that command is used to clear the current figure. So subsequent plots do not interfere with this one. Okay, and this JPEG is usually preferred if you want to use your figure, the image which you are creating, into a website, and same is PNG also. For a website, PNG or JPEG are preferred. SVG is also sometimes preferred, but that creates different formats. Okay, so SVG is comfortable for documents which might need to be scaled, just like PDF. Okay, and PNG and JPEG, they are used for embedding the image inside website. So this is what the different formats are, and they are at present saved in my this. You can see here also that it is saved just a few minutes ago, because my discussion lasted a lot. That is why few minutes. Otherwise, at that time it was showing few seconds ago. So just now created this figure on the fly, and we have saved them. Correct. Let me delete them so that next time if I want to demonstrate it, then it should be freshly created. Correct. Now here is the exercise question. In exercise also, for maintaining uniformity between learners, I have given the data frame. So you have to use that data frame only, and then using that data frame, first part is color, legend, labels, title. Next part is line plot, bar plot, pie chart, and next part is saving the plot in different formats. Okay, so you will do that, and we will meet in the next chapter. So thank you, and see you in the chapter 15. That is this chapter. Now we will take the other library. So far we are talking about only Matplotlib. Now we will take the other library, Seaborn. Okay, so I am closing this too because we have done sufficient discussion on Matplotlib. Now Seaborn. Okay, so next lecture will start with this. Thank you.